This video from the Foundation series of GMATMathPro.com deals with least common multiples and greatest common factors. We'll look at what they are and examples of how to find them. And if you're not already familiar with what multiples and factors are or the process of prime factorization, you should go back and watch the videos on multiples and factors and the videos on primes in our Foundation section. So the first question is, what is the least common multiple? And to answer that, we'll look at an example. What is the least common multiple of 8 and 12? So least common multiple is a phrase that you can just break down word by word. We'll start at the right. Multiples. You should already know what a multiple of a number is. So we'll start by listing just the multiples of 8 and 12. So the multiples of 8 are 8, 16, 24, 32, 40, 48, and so on. Multiples of 12 are 12, 24, 36, 48, and so on. So that takes care of the word multiples. Now the word common multiples would be the multiples that they have in common. And if you compare the list, you'll see that the common multiples of 8 and 12 are 24, 48, it would go on, but we'll stop there. And finally, least just means the smallest. So the smallest multiple that the two numbers have in common is the definition of the least common multiple, and in this case it is just 24. Okay, so that's one way to find least common multiples, and that way works well when you're dealing with small numbers and you're only dealing with a couple numbers at a time. You can also use prime factorization to find least common multiples, and that's helpful in a case like this where we're trying to find the least common multiple of 5 numbers. So let's take a look at how we can do that. So before we look at the harder problem, let's look at how we could have used prime factorization to find the least common multiple of 8 and 12. So the prime factorization of 8 is 2 cubed, and the prime factorization of 12 is 2 squared times 3. And the prime factorization of 24 is 2 cubed times 3. So to find the least common multiple of 8 and 12, basically we want to take the biggest exponent of each prime factor that appears and put that and build a least common multiple out of that. So if 8 has 3 factors of 2, then we'll need at least 3 factors of 2 in the least common multiple. Now 12 has 2 factors of 2, and those are already covered by the 3 factors of 2 we put in for 8, so we don't need 2 additional factors of 2, but we do need to put the 3 in. So 2 cubed times 3. And if you think back to what a multiple is, this should make sense. Like if you look at the multiples of 8, 16, 24, 32, in the other video we said that anything that's a multiple of 8 must have 8 as a factor. So if this number is a multiple of 8, it must have 8 as a factor, and it does here, 2 cubed. It must also have 12 as a factor. 12 is a factor because it has 2 factors of 2 and 1 factor of 3. So that's how you want to think about it. Now if we look over here at the harder example, we'll look at the prime factorization of 6, so that's going to be 2 times 3 for 6. 20 is going to be 2 squared times 5. 35 is going to be 5 times 7. 63 is going to be 3 squared times 7. And 75 is going to be 3 times 5 squared. Okay, now going through in the same way we did with 8 and 12, we can say, okay, I'll need at least a factor of 2 and a factor of 3 to cover the 6, and then I'll need, to cover the 20, I'm going to need one more factor of 2, so I'll put a 2 squared up there. We need a factor of 5, which hasn't been included yet, so we'll put that in there. The next number, we need a 5 and a 7. There's already a 5 in there, so we just need to add a 7. The next number, we've got a 3 squared and a 7, so we need one more factor of 3, so that's 3 squared. There's already a 7, and then we need a 3 and a 5 squared to cover 75. We've already got plenty of 3's, so we'll throw in a 5 squared. Okay, so that's one way you can do it, or you can just go through the entire thing from the beginning and just pick out the highest number of each prime factor and write it down. Either way, we get 2 squared times 3 squared times 5 squared times 7 for the least common multiple. And if you multiply that all out, we're going to get 6,300. So now on to greatest common factors. We'll look at greatest common factors in the same way. We'll break it down word by word. With this example, what is the greatest common factor of 12 and 18? So let's list the factors of 12 and 18 first. So factors of 12 are 1, 2, 3, 4, 6, and 12. Factors of 18 are 1, 2, 3, 6, 9, and 18. The common factors, the ones they have in common, are 1, 2, 3, and 6. And the greatest common factor is, as you can see, just 6. And again, that's a good way to do it if you have a small number of factors or small number of numbers to consider. You can also, again, use prime factorization to find greatest common factors. So we'll look at how to do that with this example. What is the GCF of 72, 108, and 234? Okay, so let's look at how we can use prime factorization on 12 and 18 first to get the greatest common factor. 12 will have a prime factorization of 2 squared times 3, and 18 will have a prime factorization of 2 times 3 squared. Okay, so in this case, we're looking for the factor they have in common. Okay, so we want to go through each prime factor, and in this case, instead of picking the highest of all the numbers, we want to pick the lowest of all the numbers. So one way you can do it is actually write out the factors and say, like, okay, 2 squared times 3 is the same as 2 times 2 times 3. 18 is 2 times 3 times 3. And so you can say they each have at least one factor of 2 in common, so we can circle the 2's. And now this 2 doesn't have a partner in 18 to go with, so we can't circle that 2. They also have at least one pair of 3's in common, but this 3 doesn't have a partner in 12, so we can't circle that 3. So they have one pair of 2's in common and one pair of 3's in common, so 2 and 3 are the only common sets of prime factors, so that gives us the 6 that we got before by listing out the factors. Okay, so let's look at how we can do that with the harder example. And I'm just going to list these prime factorizations. So 72 is going to be 2 cubed times 3 squared. 108 is going to be 2 squared times 3 cubed. And 234 will be 2 times 3 squared times 13. So again, we're going to look through at all the prime factors that occur and pick the smallest exponent. So they all have at least one 2. So we'll put a 2 down there. And they all have at least 2 3's, so we'll put a 3 squared down there. And then the only other prime factor that occurs is 13, but we can't include that because the 13 is not common to the other 2 numbers. So we just have 2 times 3 squared for the greatest common factor, and if we multiply that out, we will get 18.